This check-in, it's to do with the feature engineering part of the project. I do believe there's a couple of people working on various different in the different groups on the feature engineering. I've had a few messages today saying there's nothing nothing to present at the moment, which is fine. Feature engineering is quite a complex job to get done in a couple of days, and a couple of people have messaged me saying we'll send over our notebooks and they'll post them to the Slack so everyone can take a look. So we don't have to have anything to present at the moment, but has anyone been looking at the data from a feature engineering sort of view and have got any sort of ideas, any comments, or any sort of techniques that they've used during feature engineering? I know the leads are responsible for it all overall, but I would fully recommend a couple of the guides that I put into the chat. Try and manipulate the code to suit our data set and just see what happens. Experiment with it. Gordana, you've got your hand raised.
Hi everyone. I hope you can hear me well. Hi everyone.
Oh, hello, there you are. I can see you.
Okay, so I am a lead from group 4, which is vehicle analysis. And as I already mentioned, we are still working ourselves and don't have some insight, but I would like to share with you how I saw, let's say, tasks that I think that we need to explore in the future, and all of them are a little bit based from our previous presentation.
Yeah.
Because in our group we had an amazing previous presentation. They already, thanks to all of them, and they already give us a lot of insights regarding how we can move it, and it helps me really to somehow organize tasks. I see here Ovis, so thanks Ovis for your sharing some knowledge from EDE regarding vehicles. So I used it as a references. Also, I use as a references some of the notebook that you shared in knowledge sharing, etc. Okay, let me share so that I don't.
Yep. Share your screen.
So I hope
turn my camera off.
You see my screen. Can you see my screen?
Yep, we can see your screen.
Okay. From feature engineering, I will divide the objective of I think the objective of this process should be separated in some sections. So I said feature distribution, feature patterns, feature relationship, feature selection, feature extraction. Let's say like that. And then the first moment here we have what we have here regarding vehicle data set. It is that we have a couple of a couple of features that are numerical, and the histogram of each numerical feature. So maybe as we can see here, there is a lot of normal distribution. So maybe my task will be working on maybe it should be interesting to will it be interesting to work on transformation the data in the normal distribution? Maybe that can be one question for all of you, or will you?
Yeah, well, not all models take into account a normal distribution. So it might be a good idea to experiment with a couple of models and just see how they perform on these sort of features alone. And in one experiment, normalize the features, and then in the other experiment, leave them as they are and see how the model, just use a very simple model and just to get an idea of how it performs. As I say, when it comes to model development, I imagine that we'll be running through a number of different models to find out which one's best suited for our data. But it would be good to have the knowledge of our experiments before we get there. So, you know, normalize the one set of data and leave them as they are on another set of data. Run them through a model, run them through feature importance, and just see if there's any sort of effect that, you know, transforming these features has, and make a note of it and share it with the group, because, you know, each group will be having these sort of same issues and asking the same sort of questions about whether they should normalize or not. So let's do the experiments and see. That's how we're going to find out what's best for us. And, you know, we'll be able to then go into the model development stage strong, knowing exactly what we need to do. So yeah, I'd experiment. But yeah, it's a very valid question, and it's one that is asked in data science all the time. Do we need to normalize the features? Depends on the model, but it also depends on how it affects our model's performance. So I'd do something very basic and experiment it by plugging it into, you know, a couple of, you know, classification models. Yeah, that's okay. What I'd recommend. Do the experiments and we'll see. Varun has just popped in a question. Is there a way to create a correlation graph or correlation matrix against our targets? Yes, there is. That is also a very good way to see, you know, what features are important to our target variable. And, you know, that is part that can, you know, it's a gray area between a correlation matrix falls in EDA, but it also falls in feature engineering as well. Yes, you can also use the seaborne heat map. That's also an option as well. So yeah, I would recommend everyone take a look at a correlation matrix or a seaborne heat map and take a look at, you know, what features are able to tell the story to lead to the target. But yeah, so that's good question.
So Rich, so our target metrics, target variable is categorical. So how can we plot a heat map against that, like using target variable and other variables like numerical variables? So how can we use numerical variable against categorical variable to create a heat map?
I'd just leave out the target variable, and what else is there to do? You could also do a chi-square test against categorical variables. That is also another method. I've recently done a chi-square test for some NLP, and I'll share that code. It can be easily manipulated to suit our needs. So that is also an option. Yep, Faison's just said as well, a chi-square test. But yeah, and you can convert them into numerical as well. We're probably better doing all three and just seeing what we come out with. But yeah, try a heat map correlation matrix. You could also remove the target variable from the correlation matrix and see what the features are talking about in themselves, if you know what I mean, and see which features are aligned and which ones are not in respect to each other. That's also an option. It doesn't necessarily tell the story towards the target, but it's also nice to sort of, you know, to see what ones are correlated and what ones are not. Yeah, okay. Gordana, please continue.
Okay. Thanks. So then the second section will be feature patterns, which will maybe include detection, outliers, missing values, and coding, because in our dataset we have 18 18 features with type of object, and the previous group already detected, for example, age of vehicle, the feature age of vehicle has outliers, especially because they So they said that the vehicles of age between 1 and 7 holds almost 43% of the whole data sets. So it will be exploring other features, and also they plotted the engine, the features regarding engine capacity. And so here also I calculated the number of samples, the number of the samples that contains, for example, outliers, thresholds in, for example, feature age of vehicle. So here it is 51,000, almost 51,000. So that will be maybe some technique. So here it will be some technique regarding detecting outliers and working on that in a couple of experiments.
Yeah,
yeah,
absolutely. Yep.
Oh.
Usually this, you're using the the interquartile range to detect and remove outliers. Now, this is interesting because what we've seen from EDA in features such as the casualties, some of them are really high, 68, I think the top one was, or 63, and that would, statistically, it is an outlier. It's rare, but it has happened. And that's where our domain knowledge comes in. So again, this would be very interesting. If we remove the outliers based on the interquartile range that you've set, it would be interesting to see how this affects the performance of the model, where we build a simplistic model using the original data without any outliers, because some of the outliers that have happened, they've happened in real life, so it is a valid data point. And then we can also get rid of the outliers using your code and see how that affects the model in the model production stage. Again, that's what it's all about. The feature engineering part and the model development is about iterative experimentation. So all these, the interquartile range, removing the outliers, let's just see how it affects a model and its performance. It might do great, it might do worse, we don't know, but it'll be very interesting to find out. And that is something that I want to drill home, is that's what the project is that's what it's all about, is experimentation with different techniques and different angles of attack. So yeah, if that's what the if it's coming out to be 51,000 outliers we can remove, let's try it. There's no harm. This is where we can do this kind of experimentation with and learn from it. So yeah, good work.
Okay, and we have a lot of category, as I said earlier, we have a lot of okay, I didn't work on it, but we have a lot of regarding encoding, we have a lot of features that are categorical. So exploring the different, is it better that first we select? So my question is in context selection, or which of them we will use it to encode it, or will we try to encode as much as possible of them because it is 18, or in which context we are going with encoding the categorical features? Maybe some.
Yeah, we will need to do some encoding, but encoding depends on how what variables, what features that we're going to encode. It will increase the dimensionality of our data set, but they speak in numbers, so we do have to do it. But that's when the dimensionality reduction techniques come into play, the feature importance come into play. We wouldn't want to just put a raw data set with 50, 60 features all encoded. We would do some dimensionality ones, especially on the Boolean variables where it's true or false, yes or no. You know, we can get the same information by just removing one of those features and saying, you know, if it's 1, it's yes, if it's 0, it's no, and we don't need the extra feature to tell us otherwise. So yeah, we would, you know, that's something that we do have to do. But as I say, you know, when we get to the sort of dimensionality reduction, we'll reduce the overall data set size to make it a bit more, what's the word? A bit more sort of coherent and easier to digest for the model.
Okay, because we can see here which of them are, for example, okay, vehicle type, a lot of them are cars, so they already investigated, a lot of them are car types, so it is maybe not important, but on the other side, we have manual, which maybe can be important, and also make and model are the one that we saw that from okay, this here I just want to show
Yeah, so see the bool variables, they're the ones, if we do encode them, we would be able to, you know, we would be able to drop one of those columns it creates, because we'd only need the information of one column, like the sex of the driver, male or female. If we encode them to 1 or 0, it's going to make 2 columns, with one with a 0 in when it's a female, and when it's a male, it's a 1. We can get rid of one of them columns, because we know if we just have one column, 1 means female, 0 means male. We don't need the second column. So just to clarify that. So again, it's the case of dimensionality. We don't need all the columns, and we can do that in the code. In the one hot encoding, I'm not sure about get dummies. I can't remember. I don't really use it that much. But one hot encoding, you can drop the first. If you've got a Boolean value, you can drop the first column, and it'll only create 1. So that is, you know, that is the technique I'd use.
Okay. Encoding, okay, relationship, regarding the relationship, they already a little bit analyze correlation matrix. Here is just a little bit adaptation so that we can here clearly see where we have weak, strong, and medium correlationship, and in the next phases we will explore in detail some of the correlationship between some of the features that will be, and then also okay, here the next phase is feature selection using some model for scoring the features and feature extraction in context of creating new variables based on data, so that we can reduce the functionality. So that is how I think that it should be objectives of the work. Did I miss something, or should I need to add anything?
I think it's a good start. We're on the right track with the vehicle data. So we've been asked, what is the target variable for the vehicle data? Now, in the group's talk about the vehicle data, we're not entirely sure whether or not making a predictive model will be the right way to go yet. What our original intention was to perhaps figure out, you know, make a prediction of what vehicles are most likely to be in accidents or whatnot. However, the problem is all our data is vehicles that have been in accidents. We don't have the data on the vehicles that haven't been in an accident to make a fair analysis. So at the moment, we're sort of toying with the idea of supplementing this data with, statistics about registered vehicles on the UK roads, and trying to make a comparison to see, what percentage of vehicles on the UK road are in accidents. And, it'll be vastly imbalanced because, not every vehicle's in an accident. So we're not entirely sure where we're going to go with it yet. That is still up for debate at the moment. It might be a case of, rather than making a predictive model, if we can't get the data to supplement, we could make a predictive model. To make a predictive model, we could then, we could scrap that idea and maybe create some sort of dashboard or analysis which is able to draw some insights of, what kind of vehicle are involved in accidents, what are the engine sizes, what are the makes and models, and we can see which ones, why these vehicles have been are in accidents, and what makes that more likely, just as a static analysis kind of thing, if we can't find any data to supplement it with. Because if we make a predictive model now, it's going to be completely biased because we've only got accident data. So which model, which vehicle type, and we can analyze the data we do have and say that, the vehicles we have based on the accidents over the past 10 years, it seems to be they have these particular set of attributes. So we can then take that information and compare that to registered vehicles on the road and see if it makes any sort of sense to say vehicles with this particular set of attributes seem to be more likely to be in a collision. We don't know yet, but that's part of not every solution requires machine learning. When you're in data science, it's the whole aspect. It's the data and analytics as well. It's a very gray area. So if we're going to come with a solution and it brings each group's results, yes, we're going to be able to do the prediction severity, not a problem. We can use a predictive model for that. But the others, we're going to have a geospatial map. So we'll be able to plot on a map where these accidents happen, where are the severe accidents, where are the slight accidents, and we'll be able to zoom in into each sort of small part of the UK. The second part will be, the vehicle analysis. What does our data say about the vehicles that are involved in accidents, and is there any insights we can draw to and to talk to vehicle manufacturers and say, we've seen, Ford cars with this particular engine type, with this particular, or even this particular color, or this particular age of driver seem to be in accidents more. It's not about, not every single group will need to be, to build a model kind of thing. But what we can do is get all our insights and build it into a solution. And that's what the data science part is. We experiment with our data. We draw insights that previously may have been unknown, and it's about the whole package. In industry, if we're building a solution for a client, there might be only one or two people working actually on a predictive model. The rest might be working on, how to structure the data and analytics of the, and what does that say about the data that we've been provided with. What we're doing is building an entire package for the clients, which would be, say, the UK government kind of thing, and it's going to have insights from every single angle. So do we need to have a predictive model in the vehicle analysis? No. Is it possible? If we can supplement the data, yes, it is possible. But I feel like it might be inherently biased. So we might go to the sort of interactive dashboard approach and just release some insights, make nice presentations about the data we found, and we can offer that then with it accompanied by everything else as a proper full solution to someone, and we can create a website with that and just have all these intricate details. But again, the feature engineering isn't just about making a model. Feature engineering can also go into the data analytics. We're not going to use every single feature within our vehicle data set to provide them insights. what is useful to a local government or a local authority. They probably won't care, what kind of tires the vehicle has. They want to know, what make and model, what sort of engine capacity, where it's happening, and and how many injuries this is leading to. So the feature engineering part is equally invalid in just the sort of analytics side as well. And that's why I split out this project into these particular groups, because we've each got a team working on a piece of the puzzle. And when we all come together at the end to build the final, solution, all our insights will be valid, and there'll be a section for it. And not only have we sort of gone through the model build and production build, because when we get to the model build and deployments, we'll all be working on that together anyway. So not only have you sort of built your machine learning skills, you've also built your data analytical skills. The experimentation has built your data science skills as well. One of the biggest sort of, at the moment, the way artificial intelligence and machine learning is currently in industry, everyone wants a solution built by machine learning, and sometimes the right solution isn't to do with machine learning, but it needs the professionals to understand that and be able to offer a solution. So yeah, that's the purpose of it. Group four could build a dashboard as the final solution. The final solution is a dashboard with all our insights from every group. We're going to have an inference part of the dashboard where someone can upload a batch of traffic data and predict the severity, while the other pages on the dashboard are going to be about the insights. They're going to have the heat map, the geospatial heat map on there as well. So there's many different avenues we can get down, but I split it out so we could all work on a separate piece to try and reflect what it's like in real life, all working towards a common goal. Always, you've raised your hand.
Yes, Rich. So can I share my screen?
Yeah, of course, go on. But that was fantastic work so far, Gordana. You're on the right track. Discuss with the team that you're in for a bit more detail, and by Saturday we should have something very robust. Great work.
Can you guys see my screen?
Yep.
So, sir, I was following Sir Salman's tutorial on YouTube. He was trying to teach us the imputation techniques. So I started to go. I followed him, and so he actually removed the columns that had 3% to 5% of null values. And then I wanted to just go on with this approach and do a more basic approach towards, like, instead of doing using Canon imputer or any other imputer, I just wanted to I dropped the values that had up to 5% missing entries. I dropped them, and the rest of them I just replaced them with let me walk you through the notebook. So these are the columns that has up to 5% missing values. So I dropped these columns, and then I checked their distributions and just to see if it affects the distribution, the imputation affected the distributions or not. And yeah, and then this was a tip that Sir Salman taught us in the tutorial about checking the categorical features, checking if the effect of imputation on the categorical features. So yeah, so I have after dropping the column that has up to 5% missing values, this is what we are left with. And these three columns, these three columns which has more than 5% missing value. What I did that in the second row class, we had unclassified which was missing data, so I replaced them with data missing. Similarly, in the junction control column, we had data missing out of range. So I replaced them with data missing. And yeah, so this is after the imputation, or just after replacing the missing data with just data missing. And then I was checking the categorical effect of categorical features, imputation on categorical features. So this one looks fine, but yeah, this column LSOA of accident location. If you can see, after imputation, we can see that it is affecting the distribution of this column. Like
Yeah.
here it is. Yeah. So I decided to drop this column.
Yeah.
And then yeah, so yeah, here another thing, that in junction control column there is a misspelling in auto traffic signal and this. So I just replaced this with auto traffic signal, and yeah, it concatenated with this one. And after that I converted the time to hours and minutes. So I'm looking to drop the time column as well, because it has no more use in the, yeah. And I'm also looking to drop these columns: local authority, district, and local authority, highway, police force, and accident index. So I was thinking, because I don't think it will have any direct effect on the target variable. And another thing is that these categorical features have a large number of classes. So if we don't drop them and encode them, so I think encoding, uh, after encoding, it will affect the model in a negative. So I just thought that instead of encoding them, we will just drop them, because I thought that reducing the dimensionality would be a better option.
Yeah, that's a valid point. But what I'd do again is experiment. I would, once you've label and code them, get the values for it, and just do experiments on the feature importance. Use maybe a random forest feature importance, and just see how important those features are once they've been labeled and coded. They might be important, they might not, but then you'll be able to see whether they're worthwhile dropping or not. I'd certainly do the experimentation first before outright dropping them, because there is a bit of context with your local authorities in the UK. Not every local authority gets an equal amount of funding, so that will inherently dictate how much money local authorities and districts have to spend on improving the streets and the traffic. So it might not intuitively give any sort of importance, but let's do the experimentation with it.
Okay, okay. So I will, this is what I'm going to do next. So I will do feature encoding on this, and then feature scaling, and then I will try to train a model on it and just see what the outcome. Just have a rough idea of how good the encoding and feature preprocessing performs.
Absolutely, yeah. I just want to iterate: there's no right or wrong answers as long as you experiment. Apologies about that. I didn't keep my eye on the time.
It's okay. So yeah, that was all that I had to share it.
It's good work, yeah, yeah. But as I was saying just before I got cut off, the key to feature engineering and model development, which leads, feature engineering leads into model development, it is the experimentation. So I would recommend not making any sort of drastic actions until you've experimented. I would, build have a very sort of basic random forest without any sort of parameter tuning whatsoever to test out your ideas. Run the feature importance method of the random forest on the on the data set that you've encoded with the local authorities still in, and then do it when you've dropped them, and see how, if there's any sort of difference in those the feature importance. Now, I don't know for definite whether or not those local authorities and districts and whatnot will have any importance, but based on what I know of the UK and how the funding is distributed, not all local authorities have the same access to money. So there's going to be some districts which are underfunded, who can't, don't have the money to improve their sort of infrastructure. That might add some insight into the amount of accidents and indeed the severity of the accidents. So Oasia, fantastic work, but I'd just recommend experimenting with that observation and just see what happens. The chances are you're completely right, but we don't know until we do the experimentation.
Yeah, okay, I will do it. I will try both the way.
Cool. It's interesting what you did with the time as well. That is something we could, will be definitely used in the sort of time series analysis as well, depending on the level of detail that we want to go in. We could have a time series analysis with the EDA part, looking at, we've already seen that people have done it to like the hours. It could even go minute by minute if we really wanted to. Do we probably need that level of detail? No, but it is, an avenue there. And when we're going to do the time series predictions, we need to tag, our data set with, with particular time, so we can judge into the future and whatnot. So that would be, an interesting technique that someone could borrow. But yeah, very good work. Has anyone got any questions about what OASIS has done so far, or any other insights whatsoever? Lavanya, yeah, that's the thing. We don't have a target variable in the vehicle data set, because we're not sure whether it would be a valid road to go down, because it's going to be very biased because we've only got accident data. So that's why we, in the discussions with that particular group, we weren't really sure what, if building a model would be worth it. Probably if we can't supplement the data, the best we'll be able to do is to draw insights about the vehicles involved in the accidents, and try and give a detailed analysis of what we can do and what we can say about the vehicles in accidents, and how that reflects the overall picture of how many vehicles are on the UK road. Now, there's plenty of data sources where we can get, a list of registered vehicles on the road, or even just the numbers. So we've got, say if we've got 1 million in different vehicles in our data set. I don't know what the actual number is, but say if it was 1 million, and we know that there's 60 million vehicles on the UK roads, we can say it's very unlikely anyone's going to be in an accident, but we want to know why these vehicles were in an accident. Is it related to the road conditions, which we can predict the severity on, or is there a common trend in the vehicle data which seems to say these vehicles are in an accident, quite a lot because of this attribute or this attribute? It's that kind of information that will answer our question. Do we need a machine learning model for it? Probably not. But this is the sort of mental the mental mind frame I want you to get in. Not every part of the solution will require machine learning, but as a data science team, it's all valid insights. It's all, and when we get to the model development and whatnot, I want everyone to, even if we only develop a predictive model and a time series model, I want everyone from the other groups to get involved in that and understand how we're putting this model together, and why models aren't necessary for every part of the solution. So that's the idea behind it. So Rich, can you give a heads up for the feature engineering for group 3? I'm trying to pull things together from the references, but the time series jargon, I feel I'm running down the rabbit hole. Can you think of some features to use for this, or anyone else has something to add? We'll have a chat about that. I haven't had a look. I see that you've posted the notebook. Let me go away later on today and take a look at that notebook, and I'll give you some feedback on that. And it'd probably also be worth booking in a call with the rest of the team. Not just the group of time series, I mean everyone, where they can jump in and give some insights. Unless anyone's got any insights to give on the time series analysis, if anyone's had a look at the notebook, please, jump on the microphone. Oasis, you've raised your hand.
Yes, sir. So there are these 4 columns in the dataset: the latitude, longitude, and location easting OSGR and location northing OSGR. So isn't that the location easting and location northing, they are equivalent to latitude and longitude?
Yeah, I think it was Kevin who has basically said he done a bit of research into what these values are and what they mean. And if memory serves me correctly, we can drop the easting columns and the northern columns, or I think it's the northern ones, isn't it? We can stick with the longitude and latitude because they're accurate enough to, we can go right exactly where the accidents happened to pretty much what outside what house it was and whatnot. So based on that observation,
Yeah.
you drop them, get rid of them. We don't need them.
Okay.
Okay. So yeah, if anyone can take a look at the notebook that was shared into the time series analysis group and see if they can offer any insights. There might be a lot of jargon in there, and I will certainly take a look at that after this call, and I'll post some feedback in there and discuss, what a way forward. That's not a problem whatsoever. But yeah, there seems to be some good work so far on the feature engineering. In the geospatial, I haven't heard much movement on the geospatial feature engineering. I think Francisca is having a look. But is she in the call at the moment? I don't think so. No, she isn't here yet, but I'll catch up with her and I'll share the findings from there as well. It looks like, I mean, a couple of the people who were nominated for the time series analysis, I don't think they've stuck with the project in full. They might have run out of time or whatnot, or things of life gets in the way. It happens to us all. If not, me and Salman will try and pick it up as well and try and get something produced alongside the good work everyone else has done, because I don't want anyone to be sort of left on their own to do everything. Varun, you've raised your hand.
Oh, yeah, right. So I have a question. So,
Your microphone's very low and it's breaking up a little bit.
Data engineering that
The audio
from
your audio's dropping in and out.
So can you hear me clear now?
Yeah, that's a bit better. What were you saying? Sorry.
Is it not clear? Oh, just 1 second. Okay. Oh yeah, so I was saying that my question is specifically from the data engineering team, or if anyone else who has looked at the data of it. So with the accident data, I noticed there is one column which is registering physical facilities or something like that. So it has like so in our data dictionary there are 5 categories we have given, but when I looked at the data there were like 7 or 8. So I was not sure like how data engineering team handled those rest of the 7th, 8th categories.
Do you remember what data feature that was?
Oh, yep. Hello.
Hello. Can you hear me? Yeah. What was the feature?
So it's just a second. I'll just have a quick look. So it says pedestrian crossing, physical facilities.
Okay, and you say that there's there's 5 categories in we've got notes for 5 categories in that, but there's actually 7
So
existing in
in
the
the
data
data
set. Is that
dictionary,
what you're saying?
yeah,
Okay, let me just double check that, because if that's the
7
case,
and 8, yeah.
I will
Yeah.
go back and amend that. Okay, let me just take a quick look. So we have pedestrian crossing 1, 2, 3, 4, 5, 6. Yeah, we've got in the pedestrian crossing physical facilities, we've got 6 noted. If there's a 7th one, I'll get the
Yeah.
definition of that.
Yeah, there is a 7th, and then there is like, so we have 0 to 5, but in the data set,
Okay. Okay, what I'll do then, I'll take a look at that. I mean, we've got let's have a look. Yeah, there's a guide in the original notebook on the GitHub, and it gives you the government's guide on what they mean. But I'll just double check them, because if we've got 7 and there's only, we've only defined 5 or 6 or whatnot, there's one missing. So I'll double check that. But if 2 of them aren't important, we can certainly get rid of them and just stick with the 5. But I'll double check that and I'll get back to you on that one. Not a problem. But thanks for bringing that to our
sure, Rich.
attention. I don't think anyone's mentioned it at the moment.
Thank you.
I can't remember anyone who's dealt with that. But yeah, as I say, I'll deal with that. I'll take a look and I'll send an update to the group just in case we're missing anything. But yeah, if you could just Oasis just said, could you just type it up into the Slack channel, just so other people can take a look as well and see if there's anything that people have done? That'd be great. So
Oh yeah, sure. Yeah,
cool.
I'll take a screenshot and put it there.
Yeah, that's fine.
Thank you.
Okay, so let me just, I'm gonna open up Akansha's notebook. Is that how you pronounce your name? Sorry if it isn't, but I will share my screen. Give me one moment.
Yeah, that's Akanksha.
I'll share my screen now. Just bear with me 1 second. The laptop's really slow today. Okay, so this is the notebook that Akansha's shared, and it is for the time series. So okay, it's the EDA part, data visualization. Okay. We brought in the day of the week as well. Okay, that's fine. Yep. Cool. The years, the months. Okay. Total accidents. Yeah. So all this information that we're getting here will be quite useful for the sort of dashboards that we could create as a complement to the time series. So, okay, this is the work for, to create a time series plot. Okay. The mean, the plot accidents go. Okay. So in terms of the definitions and terminologies that you're getting confused on, is it the what the features mean within our data set? Is that the problem?
Not really. So I was just checking out a couple of like algorithms that we can
Okay.
employ later on to do the forecasting, and I came along some of the references that suggested that we either use seasonal arima and also Facebook's profit would be helpful. And also we can try like different combinations of LSTMs. But before we jump on that, I was just sort of, like running in circle in terms of the feature engineering part of it. Like, for example, one of it could be, let's say we try to forecast, the accident rates based on the number of causalities. That is something that I could
Mm-hmm.
think of, like, up until this point, but I'm not really sure if that's the right direction to proceed in.
Yeah. There's a number of there's a number of ways we could approach this, and each particular, like the LSTMs and you could use, transformers and whatnot, each require different sort of feature engineering, and it's a lot of work to basically create each individual model. So for in terms of simplicity, I'd probably stick to LSTMs, because there's plenty of guidance on them and how to prepare your data for them. I will get some resources together, and I'll basically share them with you so you can take a look. I'd also, I think it was a good idea to maybe do some sort of Monte Carlo simulation as well. And I can share the code to that. I've done some brief Monte Carlo simulations on some stock data, but we could also use it for this. So we could put, certain conditions that we see within our data, and we could, plot out 1,000 iterations of where we think, this particular direction of, and see what it leads to, whether it's going to be, a rise in accidents or a decrease in accidents. And what you do with the Monte Carlo simulation is you take the mean from that, and it gives you an idea of the sort of projection our particular features are going to give. I'll provide documentation on that as well, and I'll provide a couple of code examples. But I think for overall model building, I'd stick with LSTM for the sake of feasibility. As I say, they've been around a while, and there's a lot of good documentation. There's a lot of good tutorials on how to put them together, especially on Kaggle. So yeah, we'll go through that, and I'll provide some research, some resources for you, and we'll take it from there. As I say, let's put a call in at some point with the rest of the time series analysis group, and we can discuss it from there. But yeah, I think that'll be the best way forward, just to stop, to stop any confusion and give you the right sort of direction. Let's book a call in. So yeah, we'll do that, definitely. But yeah, I think what has been done in that particular notebook so far is very good work, and some of the views that we have will complement a sort of a data analysis dashboard part of it. And then we can build, a model to make some predictions based on an LSTM. Definitely. So I'm just but I'll what I'll do with it, because you've shared this notebook with me, I'll add some bits and bobs at the end in the time series analysis, and I'll build a basic outline model of what we would be looking for. So yeah, very good work so far, but let's get together with the rest of the time series analysis team and discuss it in further detail. Okay, right. I think that is pretty much it. This was just a check-in, and so far everyone seems to be on the right track. There's just a few grey areas where people are a bit unsure with around the time series and the vehicle analysis. But what I've seen so far, it's good work, and I'll share some information, as I say, about the time series analysis, so we can get on the right track. I think that's pretty much it. Is anyone got any sort of questions at all? What's the difference between forward feature selection and backward feature selection? Basically, if you're doing any sort of recursive analysis on your features, forward feature selection is when you well, I'll break it down very simply. You start off with one feature and your target variable. You run it, you see what the performance is like. You add a feature on the next run, see how that affects the model. You add a third feature on the next run, you see, how that affects the model, and then you can see exactly what feature adds to, what value it adds to the prediction. Where backwards feature selection is the exact opposite. You start with all your features and you take one off, rerun it, you take one off, you rerun it, you take one off, you rerun it, and see how that affects your model. There is a fantastic program called Gretel, and it's a very it basically, you can upload a data set and it gives you the sort of p-values and whatnot for your features, and you can do forward and backwards feature selection using Gretel. I don't think it'll be very good on our data set because it's massive. It's a massive data set, but if you've got a smaller data set, you can load it into Gretel, and it'll give you, all your sort of VFE scores. It'll give you your p values and whatnot compared to the target, and then you can remove the features one by one or in groups, or you can add them one by one or in groups as well, and see how that affects the model. But that's pretty much in a nutshell what forward feature selection and backward feature selection is. It's just it's sort of a way to analyze feature importance, but I'm more visual. I'd rather just run it through like a random forest feature importance method and see if with my own eyes kind of thing. But it is a valid technique, and it can be quite useful as well if you want to really go into the granular detail of what effect the features are having on your overall model performance, if that answers your question. Has anyone got any other questions at all? No? Okay. I'll tell you what then, we'll leave it there for now. I'll put the recording on YouTube later on this evening, but thanks everyone for attending, and thanks for the contributions you've made so far. We're on the right track. Of course, we've run into a couple of, spanners in the work, shall we say, but that's all part of the process, and it's good that people are realizing, hold on a minute, how are we going to do this with this particular data set? That's all part of the process. That is indication that you're learning something. Now, I purposely didn't look at the data in depth because I want to be as surprised as you when we come across things like that, and I want to work with you to figure out the solutions to these problems without seeing the data set first, or not sort of telling you the answers in a way. So I am completely anonymous to the data set as well, and I think from what people have been asking and what the concerns people have, we really are learning quite a lot. What's the last day to submit the project to Omdena? To be honest, there's no sort of deadline. We usually run between 4 and 5 weeks. It depends on how in depth, and what we want to do. I'd like to get it done within 5 weeks, so it'll be like, I think it'd be the 5th of November would be the final sort of presentation, and that's where we would pretty much show what we've done, and show the solution that we've come up with. It doesn't have to be, a working sort of deployment. We can put it on Streamlit. We can put a Streamlit dashboard together, and we can, summarize what we've done. But we don't necessarily have to have it live on AWS or a cloud service, because at the end of the day, that costs money. As long as we can provide something as a solution at the end, which will be a dashboard. It may have a inference cluster where we can batch upload stuff and get predictions. You know what I mean? We can make a working model, but if the time doesn't allow it, don't worry about that. I can fix that at a later date. But as long as we have something at the end, it's very good. There's no research papers that we're working on at the moment. The idea for this was, I did see a research paper and they used what did they use? I'll share it with you. I think someone already has shared it though, a while back, and basically they used a random forest or logistic regression. I can't remember what it was, just to analyze and predict severity, road accident severity. And I thought they only used it, I think, about 1 or 2 years worth of data though. So I thought it might be an idea to, use it near enough a decade's worth of data. We could certainly write a research paper about it though, to be honest with you. It's just time constraints, I suppose. But if we're able to deploy a nice looking dashboard with a working model in the background, which will be able to, if you're seeing Retton's model that he deployed on, I think it was the Iris data set, he had a work, you could put in certain attributes of a flower and it'd give you the prediction. We could do that with our dashboard. We could either have it, a line by line sort of thing, or we could do it, a batch inference sort of, we could upload 100 lines worth of accident data and we could predict whether or not they were severe. What is the good way to get a job in the US or UK research paper or projects? If you want to be a machine learning or artificial intelligence researcher, and that would be, you would be sort of working in the academia, you would have to have research papers. But if you work in industry for a company that makes solutions, it's generally more project based. I think experience certainly counts more than qualification. If you are a graduate in computer science from a university, but you've had no sort of industry experience, and you're up against a candidate who's sort of worked through data analytics and into machine learning through a natural, job progression sort of route, they would tend to go for the more experienced level. So that's why, even from an academic background, you need projects. You need to show that you've worked on real life projects and you've come and produce solutions to real life problems. That goes a long way. But if you're looking to be a machine learning or artificial intelligence researcher, where you're going to be developing models, that's when you would need to start to get involved in writing research papers and whatnot. It's completely different. Like, researchers in academia, they create the models. In industry, you use their models to make solutions, if you know what I mean. That's the difference. I'm not a machine engineering researcher, but I use the research to make solutions. Yep, the Omdena, it provides certification to every active participant. There's also a year-long subscription to DataQuest and DataCamp as well. So if you're an active if you've made an active contribution, you get the certificate and a year-long subscription as well, to just enhance your skills further. DataQuest is fantastic. DataCamp's fantastic. I've used both. And DataQuest offers a data engineering pathway, and it's fantastic for general Python skills. So yeah, it is worthwhile. But you can use this project as on your resume. You can use it, and that's why I want to encourage you to share the work that you've done on LinkedIn in this project. Tell people about your story, tell people about your journey, and that way you become more noticeable. Yeah, I can share my resume, not a problem. I'll have to update it, to be honest with you, with my new role, but yeah, I can share it. Yeah, definitely. So yeah, we'll call it quits there. Hassan, if you've got any more questions about anything like that, just message me on Slack and I'll get back to you as soon as I can. Find that, Junior, if you raise your hand.
So hi everyone. I would like to know what kind of organizations in UK are involved in this type of projects. I mean, HTC security project.
Well, it would mostly be the Departments of Transport, which is a a department of the UK government. That's where all this data comes from. It'd be, you know, they do their own analysis and whatnot. I'm not entirely sure whether they use any sort of machine learning or artificial intelligence at the moment. I don't really have much to do with that department. I work in the Crown Commercial Service, which is like the procurement. So I do a lot of spend analysis and customer sort of behavior analysis and whatnot. And I use machine learning I've built a few text classifiers to match up contracts and whatnot with what the government offers. The Department of Transport, I'm not as familiar with, so I will have to research on that, whether they use machine learning models already to predict this kind of thing. As I say, this was inspired by a academic paper, and I believe they were from the University of Edinburgh, but I might be wrong. I can't remember, but they used, as I say, 1 or 2 years worth of data, and they built a random forest classifier and a logistic regression, I believe it was. I'll have to double check that. I can't remember for the life of me now, but that was the inspiration. I thought, you know, we'll use a much larger data set, and we can use that to create a really, you know, formidable dashboard that allows us to draw real insights that, you know, may have been unfound until we've got hold of it, and you know, hopefully, fingers crossed, we can do that. Yeah, of course you can, Lavanya. We can you can share that, absolutely. And as I say, you know, promote yourself on LinkedIn. It's probably the best way to get a role in this sort of industry is sharing your work, showing off, bragging about what you've done, telling people about what you struggled with and how you you know, problem solved and come up with a solution. That's the best way to do it. It certainly worked for me anyway. But yeah, Dunya, I think the Department of Transport, they definitely do their analysis, but in terms of machine learning, I'm not quite sure. I'll have to get back to you on that one.
And how about universities?
Universities, yeah, well, the universities, they'll be having computer science students who will be researching that. I mean, the data set, I've seen that the data set's being used on Kaggle. It's being used in a number of sort of academic papers for various different analysis and whatnot. But I can't recall seeing anyone who's used the data as much data if we use, because I've took a total, you know, a 2 million line dump of what we needed, and so we can, you know, make a decent sort of solution with as much data as possible. The more data, the better, really. So yeah, I don't think there's anything out there at the moment. I certainly haven't seen it. So, you know, if we come up with something fantastic, we can certainly let them know. And if they want to get us to write a published paper, bring it on, and we'll all be an author on it. Absolutely. But at the time, let's just focus on making a fantastic solution. And I think it's more than possible at the moment. We've got some great insights, and we've got some great people working on it, and we're all actively contributing. So why not?
So what if we want to start to write research papers? How we can do it? Does it necessary to look for a supervisor, or just in my own, for example? I can do it in my own.
Yeah, you can do it in your spare time, absolutely. And this project, it's as much as yours as it is mine. So if you want to write an academic paper on this project and use the insights that we've drawn and used, that is up to you. It's absolutely, go ahead and do it. It'll be great to see. The original intention of this project wasn't to do that, but if that's what you want to do, absolutely. Okay,
Thanks.
No problem. We've got 5 minutes left. Any other questions before we call it a day? No? Okay. We'll leave it there then. Thanks for everyone coming. And as I say, let's catch up in Slack and make sure everyone is supported. And let's talk about. We'll have to have a meeting about the time series analysis as well. But let's leave it to that group to organise it, and we can talk about what sort of models we need to use and how we're going to approach that. That's the main takeaway. But any other questions, just message me on Slack. Thanks, everyone.
Thank you.
Thank you.
Thank you.